All right, let's dive in. Today we are talking about the absolute ground floor for any journey into data science or machine learning with Python, and that is the incredible NumPy library.
So, you're ready to start building, huh? That's awesome, because whether you're trying to analyze sales data, train some kind of fancy neural network, or even work with images, it all begins with the same thing: organizing numbers in a really efficient way. And that's the foundation we're going to lay down right now.
So what even is NumPy? Well, it stands for Numerical Python, and trust me, it is the bedrock for all things scientific computing. You might be thinking, why can't I just use a standard Python list? The reason is that NumPy is ridiculously fast and way more memory efficient. It gives us this powerful new thing called an array, and that's the star of the whole data science show.
Okay, enough talk, let's actually build something. We are going to create our very first one-dimensional array.
The very first line of code in pretty much any data science project is this one. We import the NumPy library, and by a universal unspoken rule, we give it a nickname, NP. It just saves us from typing NumPy over and over again. You'll see this everywhere. And here it is, our first array. We use np.array, and we just hand it a regular Python list of numbers. We save that in a variable, and when we print it out, boom, there it is. Looks pretty simple, right? But hold on a second. That looks, well, it looks exactly like a Python list. It's just numbers inside square brackets. So what's the big deal? Well, what's happening under the hood is what makes it a completely different and way more powerful animal.
And we can prove it's different. Using Python's built-in type function, you see the output isn't list, it's numpy.ndarray. That stands for n-dimensional array, and this thing is NumPy's secret weapon. See, unlike a list, an ND array stores all of its data in one solid, continuous block of memory. That's what allows it to do math operations at lightning speed. It's the whole source of its power.
So now that we know we've created this special NumPy object, let's figure out how to ask it questions about itself. How do we inspect its properties to really understand what we've just built?
One of the coolest things about NumPy arrays is that they're not shy. You can just ask them about themselves. We call these attributes. You just add a dot and the attribute's name. So .ndim is like asking, hey, how many dimensions have you got? .size asks, how many total items are in here? .shape asks, what's your structure look like? And .dtype asks, what kind of data are you holding?
Let's try one out. If we ask our array for its .ndim attribute, we get back the number 1. And that confirms it. What we've made is a one-dimensional array, which is basically just a single row of data.
Okay, so we've got one dimension down. Let's kick it up a notch and see how we can build this into more complex data structures. It's time to make a 2D array.
The idea here is actually really simple. To make a 1D array, you gave it a list of values. To make a 2D array, you just give it a list of lists. See that? Each of those inside lists is going to become a row in our new grid.
All right, let's go ahead and create a 2D array using our list of lists. Now look what happens when we print it. It's not just a flat line of numbers anymore, is it? NumPy automatically formats it into this perfect grid, a matrix. We have distinct rows and columns now. This structure is the basis for everything from a spreadsheet to the pixels in an image.
Okay, remember that .shape attribute? This is where it gets really useful. When we ask our 2D array for its shape, it doesn't just give us one number. It gives us 2, 4. This is a Python tuple, so what in the world do these two numbers actually mean?
The rule is super simple. It's always rows first, then columns. So a shape of 2, 4 just means our array has 2 rows and 4 columns. That's it. This is the fundamental way we describe the structure of our data from here on out.
Fantastic! You've just put together a foundational toolkit for working with data in Python. So let's just do a real quick summary of the new commands you've got under your belt. So you can now import NumPy, you can create these powerful ND array objects, you can prove they're not just lists, and you can inspect their core properties like dimensions, size, and shape. This isn't just a list of commands, it's the basic vocabulary you'll use to handle data in pretty much any project you can think of. You've just taken the first and most important step. You can now create and actually understand the core object that's used all across data science and machine learning. So the only question left is, what problems are you going to solve with it? That's all for now.